Hey everybody, it's Beej with Lambda School, and today we're going to be talking about how to do animations with a React app, with a canvas specifically within a React app. So normally with the React app, you do things like set the state, and that causes everything to be re-rendered. But here we want to do things a little bit differently. We're just going to have one canvas component that gets created and drawn once, and then we're going to start an animation loop to manipulate that same canvas. It sort of bypasses the normal set state stuff that you're used to with React, and in exchange we can get way more speed out of our animations. So in order to get started, first thing we'll do here is create a React app from scratch, and I've gone ahead and taken the liberty of doing that. And what do we got here? I've created an app called requestAnim, and we'll pop over and take a look at this. So this is just your standard React app with an index and an app.js and so on. So this is where we'll do all our work. So it comes with that stock app, and we'll rip that out and have some fun times here. What we want to do is we want to create our own React component that is a canvas. And then we will animate that canvas using JavaScript built in that causes frames to be called repeatedly very quickly. So first of all, let's go ahead and pull all that out and go ahead and we'll make our own component here. So there's our component, and then we will have one of those in here. Actually, I guess we can do shorthand in here, can't we? So there we go. My component we get put in there, and in render, we're going to render a canvas element. And we'll just go ahead and hard code a width and a height in here. Although that might be better passed in. All right, so we've got our render there. And what do we have to do? What do we have to do to make this work? We're used to our normal life cycle stuff. But here we want to do something a little bit different. We want to call a function called requestAnimationFrame. And what this does is it says, hey, browser, as soon as you can, I need you to make a callback for me to tell me it's time to render a new frame. requestAnimationFrame doesn't actually render anything. It just repeatedly calls a callback. It's very much like setInterval. If you called setInterval with a very small number, like 30 milliseconds, it would behave very similarly to requestAnimationFrame. So let's look at the normal lifecycle stuff that goes into a React component. We've got component did mount. So that's when the thing gets created and added to the DOM. We want to, when it does mount, let's go ahead and request an animation frame. So request animation frame, we give it a function to call, a callback, and I'm going to tell it that we want to call this dot on anim frame, and that should get us our animation frame. Now it's notable that request animation frame only causes the callback to happen once. So it's not like set interval in that set interval will repeatedly call this thing. Request animation frame only does the call once. So I guess it's a little more like set timeout. If you called set timeout with an argument of 30 milliseconds. Let's have an on anim frame function. This thing actually takes a timestamp as an argument. So you got the timestamp parameter here, and you can use that to figure out what time it is right now in milliseconds, I believe. And you can use that to compute how many milliseconds have elapsed since the last time you got an animation frame if you have to do something with timing. Then let's look at component. Let me actually do this first. After we do animation stuff here, we want to get another animation frame. We want to request another animation frame because, like I said, it only does one. So let's request another animation frame at the end of this. Exact same thing. So what this will do is when the component mounts, we request one animation frame, and then we get this callback, and then we do some stuff to animate things, and then we request another animation frame. And then on the next frame, probably about 30 milliseconds later, we'll get this callback again, and we'll do some stuff, and then we'll request another animation frame. Now, note there is something a little funky here in that if the component unmounts, we're still going to be requesting animation frames. This code we're writing here has no concept of what React is. So really, when the component will unmount, we want to stop doing this stuff. So I'm going to go ahead and add a little helper here, continue animation, and we'll say continue animation true, and then we'll, when the component will unmount, we will say this dot continue animation is going to be false, and then we can put this in the conditional. If we're continuing the animation, then do this stuff. So this way, when the component will unmount, the animation will stop. Now that's almost all there is to it, but we do want to animate that canvas, right? How do we get a reference to that canvas? If you watched the previous example where we did stuff in just pure JavaScript and HTML, we used document.querySelector to look it up by ID. But we don't know what the ID is going to be. And this thing could come and go. It could mount and unmount and mount and unmount. Who knows? React has a way of getting around this. You can add something called a ref, which gives a name. My canvas gives a name to this element that it creates. And you can look up that name in this .refs inside the component. It's going to be called my canvas. This name right here, my canvas, exactly the same name that we give it here. So now we have the canvas. And if you've already watched the other video about contexts, we can get the context from the canvas. And then the world is our oyster. We can draw all kinds of stuff. And we can change the positions of things that we're drawing on the canvas, and so on. So, for example, if we had an image like a potato that we wanted to draw on the canvas at a certain point, we might have that coordinate stored somewhere. We'll have an XY coordinate stored for the potato, and every frame, remember these are happening every 30 milliseconds or so, we can increase the X coordinate by a small amount because we're getting frames so often, we'll want to increase it by a small amount, and then you can draw your potato on the screen at that coordinate. So that's one way of getting stuff to animate. The kind of catch is here, though, we don't actually know how often onAnimFrame is going to get called. We're calling requestAnimationFrame to get them as quickly as possible, but it could be 30 milliseconds or 20 or 40, or it could be almost anything. The timestamp is what you actually need to use to figure out exactly how much time has elapsed if you want to move a thing by a certain number of frames per second. So right here, we're just drawing the potato every 0.1. We're moving it 0.1 every frame. Who knows how fast that actually will make it. So you can do something similar to this. You can have a previous timestamp, and we'll set that to null ahead of time. And I'm going to get rid of our potato stuff. So we have our previous timestamp as null. We have our current timestamp that's getting passed in. So we want to know how much time has elapsed. And this will be in milliseconds. So let's compute that. Normally, time elapsed would be equal to the previous, the timestamp minus the previous timestamp. This previous timestamp. So this would normally be our time elapsed, but of course we've initialized our previous timestamp to null, so that's no good for doing any kind of math. So a common trick is to just fake it until we actually have a previous timestamp. And then of course we'd set previous timestamp to timestamp, so it would know it for the next frame. But if previous timestamp is null, then what do we want to do? Let's just put a little conditional in here. If this .prev timestamp is null, then let's set it to the prev timestamp is equal to timestamp minus 30. So we're saying we don't actually know how far in the past the previous timestamp would have been, but let's just go ahead and pretend that it was 30 milliseconds earlier. So then our previous timestamp, it has a valid value in it, and then we can use it to do our regular math, and then we'll save it for the next time. And now, of course, at this point, time elapsed holds the amount of time that has happened since the last frame. So now you might have to do some math, but you have this important number to figure it out with. So if I wanted to move an object across the screen at 30 pixels per second, how far do I have to move it this frame if this many milliseconds have elapsed? So it's sort of a math problem. You might remember from algebra, there's this formula called the distance formula that can compute the distance for a given speed and time. So that might be useful, since we seem to have a time elapsed, and if we know our speed in pixels per second, then we should be able to figure out how far to move the thing this frame, right? Keeping in mind that time is in milliseconds, and speed is probably in seconds, pixels per second. And as a hint, 1,000 milliseconds is the same as 1 second. So maybe using all these things, you can figure out how to move something across the screen in a reasonable amount of time. Because that's your little mini challenge here. Move a pixel across the screen at this specific speed. Let's go ahead and print stuff out and make sure that this is working and debug it if it's not. So we got canvas, this context, get 2D. So right here is where we draw things on the canvas. But I'm just going to actually console log some stuff here. We'll just console log timestamp and timestamp yield timestampy, timestamp and time elapsed. We'll just push those out to the console and see what happens. And if this doesn't work, then we can debug something. Undefined and nan. All right. Let's debug this and see what's wrong. Alrighty. So what we seem to have here is a problem with getting the timestamp into our anim frame callback, and that is, of course, because it is not getting passed in our function. So I'm going to go ahead and put timestamp here and get it passed in, and then we'll do the same thing down here. And then hopefully that gives us a better result. All right, so here we have our animation frame. The left is the time elapsed so far in milliseconds, 8 seconds, 9 seconds, 10, 11, 12, 13. So there's our seconds counting off. And on the right, we have the number of milliseconds that have elapsed since the last frame. So it's a pretty consistent 16.6 milliseconds have elapsed. So we can use that information to move a pixel across the screen at a certain rate. Using that distance equals speed times time formula. So give that a shot. And after this, we can use this animation loop to do all kinds of good stuff, animating on the canvas at high speed. Have fun.